Hi, everybody. My name is John Frensley, and I'm going to work out the AP Calculus free response questions that were just released today. This is 2026 released exam. If you don't know me, it's because I'm not well known in the calculus community. I actually teach AP Physics, where I'm actually very well known in the physics community. So you all probably know this already, but if you'll just humor me, both the AB Calculus exam and, okay, don't have time for pens that don't work. Okay, there we go. And the BC calculus exam have two questions that are yes, calculator, and then four questions. One, two, three, four. Four questions that are no calculator. One, two, three, like so. 1, 2, 3, 4, 5, 6. I better be able to count or else I can't do calculus. Now, can I? Right? Okay, now the first question is an AB and a BC, okay, that appeared on both exams. And then this one is AB only, and this one is BC only. Did not appear on both exams. Then, once we get to the no calculator section, we'll have two questions that are both on the AB and the BC. Okay. And then we're going to have two questions, B and the BC. Okay. And then we're going to have two AB only questions and two BC only questions, right? Pretty straightforward. All right. So that is, if you count, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 questions I've got to solve. So what I'm going to do first is I'm going to do the yes and 2 no calculator questions that were on both exams. Then I'm going to do the 3 questions that were on AB calculus only, and then the 3 questions are on BC calculus only. I'm going to try to make this video go as fast as possible. That's 9 questions for me to do. Now, if you'd like to calculate the number of questions that I'm going to enjoy doing, all you have to do is take the natural log of the log base 2 of the log base 3 of 9. Yeah, if you can just do that, then you can figure out how many questions I'm going to enjoy doing. And if you like that, then you can find out how many times I'm going to curse in this video by taking negative natural log of that number, right? That's how many times I'm going to curse in this video, because I don't really love calculus that much. It's a tool, but it's like, that's pretty much all it is to me. It's a tool. Okay, so we got this. Male birds of a certain species arrive at a nesting area over a 30-day period. Is there a reason why they have to be male? The rate at which the male birds arrive, okay, this is birds per day. So this is like the derivative of a function of the number of birds that are there. Okay, it's modeled by the differentiable function m, where m is measured in number of birds per day. Here's selected values. Okay, this is an insult. They put this on the AP Calculus exam. Make sure your calculator's in radian mode. Okay, well, I'm pretty sure mine is in degrees because that's what we use a lot in physics, right? So I'll put my calculator in radians, okay? I can't believe they put that. This is such an insult. Okay, approximate m prime at 7.5. That is exactly in between these two. So using the average rate of change of m, so really all you're going to do is you're going to just say 16 minus 7 over 10 minus 5, which is 9/5. Okay, show work that leads your answer and indicate units of measure. That would be birds per day squared. So it's like the acceleration of birds, right? It is birds per day divided by days. So that's going to double or that's going to square the number of days, birds per day squared. Okay, use a midpoint Riemannian sum with these 3 subintervals to approximate the integral of m, okay, and then interpret the meaning. I'm going to go ahead and tell you what the meaning is. The interpret the meaning would be this is the number of birds that arrive during the 30 days after, time equals 0. Okay, so because m is a rate, then that means that the integral of m is an accumulation. How many birds did we accumulate? Okay, so now I'm going to do this midpoint Riemann sum. Okay, so let's see. From 0 to 10, the midpoint is 5. So the base is 10. And the height is this number 7. Sorry, that number 7 right there. So the base is 10. That's the width of the interval. And the height is the height of the midpoint. So this is a rectangle's area. Then this base is also 10, but this height is going to be 6. And then this base is also 10, and the height is going to be 2. Okay, so 70 and 60 and 20 is 150 birds. Yeah, number of birds. Okay, so that's approximation of the number of birds that arrived. And I have not needed my calculator yet. Okay, I've not needed my calculator yet. Okay, the rate at which the female birds. Oh, okay. Now, this might be important, okay? Of the same species, how heteronormative is this? You have to wonder if I'm being sarcastic or not. Arrive at the same nesting area in birds per day is modeled by this function. For the first 15 days, they are sitting on the couch and eating bonbons and watching soap operas or something like that. Then they finally get up off their lazy butts and start showing up. How many female birds of this species arrive from time 15 to time 45? Okay, hang on a second. This is birds per day. So I just got to integrate this. This is a rate. F of t is a rate. So I just need to do integral from 15 to 45. 18 plus 16 sine pi over 20 t plus 15, which technically I could do without a calculator, except I'm allowed a calculator on this part. So why am I using, why am I, okay, well, whatever. Okay, so this is math, function numerical integration. We'll go from 15 to 45, and then so this will be 18 plus 16 sine pi over 20 times t plus 15. I think I got to close the parentheses on the sign also. Let's see how it chokes this down. 641 or 642 birds. Okay, so 642 female birds. Okay, there's only 150 male birds. There's like 642 female birds. Maybe they're Mormons or something like that. Who knows? Okay, on the interval that the difference in the rates at which the male and female birds of this species arrive at the nesting area can be modeled using this differentiable function, where f is defined in parts of. Okay, now I got to pay attention. Is there a time in the interval when d is equal to 0? Okay, now I got to slow down here. Okay, so d is just the difference between this, and we're looking from 15 to 30. Okay, and what I notice is that m, which is differentiable, which means it's automatically continuous, goes from 6 to 0, and it could wiggle up and down for all I know. I don't know, but I know that if it's differentiable and therefore continuous, m has to visit every single number, not 6, 5, 4, 3, 2, 1, 0, but every real number between 6 and 0 if it's differentiable, which means it's continuous. Is there a time when d equals 0? In other words, is there a time when m of t equals f of t, right? Okay, well, we know that m of t must take on every real number from 6 to 0 as its value on this interval. Okay, so from 6 to 0, we have to visit all the real numbers because it's differentiable, which means it's continuous. Now, let's look at f of t. Oh, what am I doing way up there? Okay, f of t, we're going to start at 15 to 30. Okay, so 15 to the, what the devil is all that? That's not even what I'm asking about right now. That's like crazy crap. 18 plus 16 sine pi, oops, not e, pi over 20 times t plus 15. Okay, let's see what the 2. So I'm going to say yes. Okay, the f of t increases from 2 to, let's have a look at what it increases to. 29.3 on this interval. So f of t being continuous must take on every real number between 2 and 29.3. So at some point, both m of t and f of t have the same value. So yes. Yes, this can be 0, or it must be 0. And by the way, can I tell you, if there are any AP Calculus readers here, are you sure you meant to say is? Did you not mean to say must? Must there be a time t in the interval when d equals 0? Like, can we, that's important language in my opinion. Okay, so this is the AB only question, so I am going to come back to it. Oh crap. Okay, I'm getting my pages mixed up. I apologize. Okay, so I'm going to come back to it. Okay, this is the first of the no calculator questions. I will keep my calculator handy because I can cheat like that. I'm not actually taking the exam, but I'll try not to use it if I don't have to. Okay, a pie is taken from a hot oven, put on the table. The internal temperature of the pie is modeled by this function h. Okay, we have a differential equation. H is measured in degrees Celsius, and H at 0 is 75. Oh, I was like, there's no way this is the slope field for that. Explain why the following could not be a slope field for this differential equation. I don't know. How about the fact that for h greater than 20, dh dt is negative, and not a single slope here is negative. Is it a whole? I'm just going to tell you right now, the readers did not write the question, okay? And the readers may hate it more than you do because they have to spend 8 days reading it, okay? So they may, so insulting the reader is I mean, they're still going to score you, right? But you're not accomplishing anything with it. Find the slope of the line tangent of the graph at time 0. Great. Y minus y. Oh, we'll find the slope of the line tangent, like not even right the tangent line. Okay, well, dh dt. This is an insult, right? Is all the AP exams just stupid now? Because the physics ones that they've already released are like really sad. Okay, so this is going to be negative 1 over 15. What did they say? H at 0 is 75, and they said at t equals 0. So that's 75 minus 20. Okay, now I don't get a calculator for this, so I'm just going to say negative 55 over 15. Really not feeling like simplifying this, but maybe I will. 11 over 3 degrees Celsius. H is in degrees Celsius. And does it say that t is in minutes or something like? Does it say? T minutes. Okay, degrees Celsius per minute. Okay. It can be shown that this, yeah, you can show that by actually making us take the derivative. Just the exam is taking itself for us. The line tangent to the graph of h at time equals 0 is used to approximate h at 5. The internal temperature of the pie at time equals 5. Is this approximation over or under? Okay, so understand something fully. So d squared h over dt squared is positive for 0 is less than h is less than t is less than 5 minutes. Okay. I don't actually know that, but I'm pretty confident that it is. Okay. So I'm going to say this is positive during this time. So the graph. Oh, and I'm going to say this. I'm going to say and dh dt is negative. So I can already tell you what the graph of h is going to mostly look like, okay? It's mostly going to look like this, okay? In fact, this is just Newton's law of cooling. So I can absolutely tell you what's going to happen. Like, you didn't need to know this, but it's asymptotically going to reach 20, okay? That's what it's going to do. Starts at 75 and lasts 20. So what are we going to try and do? We're going to try and approximate h at 5. Is this approximation over or an underestimate? It is, in fact, an underestimate, okay? It's going to be underneath, right? So I'm going to say this. I'm going to say, okay, I'm running out of space here, so I'm going to go ahead and put part C right here. Okay, so for part C, I'm going to say, since d squared h over dt squared is positive, the graph is concave up. So any line drawn tangent to the graph will pass under, and it does pass under the graph on both sides, by the way. So on the other side, if you could extend the graph of h, then the line will also be underneath on the other side. Oh, it's an underestimate. Okay, there we go. Now part D. use separation of variables to find an expression for h of t. Oh, sure. Now we're actually doing some real MFing calculus. dh over dt equals negative 1 over 15 h minus 20. This is exactly the same as one of the differential equations. It has the same form as one of 5 differential equations that we do in AP Physics C, Mechanics, and EMAG. So I can basically do this in my sleep. So we just cross multiply and we cross multiply. The top is exactly the derivative of the denominator. So because the numerator is exactly the derivative of the denominator, then the result is natural log h minus 20. And this is negative 1 over 15t plus a constant. So I'll call this C1 because I'm going to bring this over. And it's going to become e to the negative 1 over 15t plus C1, which is the same as e to the c, which is another c. Okay, right. And so h is going to equal C2 e to the minus 1 over 15 times t plus 20. Okay, so h equals 75 is what we were told, right? At t equals 0. So 75 equals C2 e to the 0 plus 20. E to the 0 is 1. So I'm going to say C2 is 55, which is the temperature change. Again, this is just Newton's law of cooling, so I'm quite familiar with this before it was even on the frickin' AP exam. 55 e to the minus 1 over 15 times t plus 20. At time equals 0, then 55 plus 20 is 75. At time gets huge, it's going to asymptotically approach 20, which is where the slope will equal 0. Okay, so that's the story there. Okay, this is the other question that was common to both forms of the exam, AB and BC. Let f be a twice differentiable function. Glorious, okay? On the closed interval, negative 4 to 4 with f at 2 equals 3. The graph of f prime. This is the graph of f prime, not the f itself. For x greater than 0, the function g is defined by that crap minus natural log x. Find g prime of 2. Well, g prime of x would be f prime of x minus the derivative of natural log is 1 over x. So g prime of 2 would be f prime at 2 minus 1 over 2. What is f prime at 2? 1.5. So I get 1.5 minus 0.5 equals what? Find all values of x on this open interval at which the graph of f has a point of inflection. So a point of inflection, so point of inflection is where f double prime equals 0, which is where the slope of f prime equals 0. And if they're going to only restrict me between 0 and 3, then that's just going to be at x equals 1. Okay, for this, negative 4 to 4, which is what I'm seeing here, on what open intervals, if any, is the graph of f both increasing and concave down? Okay, increasing, okay, means that that f prime is positive, okay, which means the graph is above 0. Okay, so that only happens between negative 2 and 3. Now, concave down means that the second derivative is negative. Okay, that means that the slope of the given graph is negative. So that's between open interval x equals 1 and x equals 3. So that'd be 1 is less than x is less than 3. For this whole thing, find the value of x at which f has an absolute minimum. Okay. At which f has an absolute minimum, and the value of x at which has an absolute maximum. Give reasons for your answers. Okay, so let's start here. So starting here, the graph. I'm actually going to try and sketch the graph of f here. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Okay, this is my best guess of the graph of f. And it doesn't matter where you start because that's your plus c, right? It doesn't matter where you start. So I guess I'll start at 0. But what I immediately notice is that I have a negative slope, and that negative slope is getting steeper, then less steep. So negative slope is getting steeper, then less steep. As the derivative gets more negative and less negative, the slope gets more negative and less negative. Then the slope is going to get more and more and more positive, steeper and steeper and steeper and steeper positive until here. That's the steepest it's ever going to get. And then it's going to get less and less and less and less and less steep. And then it's going to get steeper again, okay, as this goes up. All right, so I am going to say this. I am going to say the absolute minimum must be at x equals 3. The absolute minimum must be at x equals negative 3. I meant to say x equals negative 3 because starting from x equals negative 4, the integral of f prime dx from 0 to, let's say, t. You're not really supposed to put this variable and this variable be the same, okay, is negative is a negative area until, did I mean 3? I meant to say 2. I think I meant to say 2. Sorry. At x equals negative 2. Sorry, at negative 2. Negative 2 is where the negative area ends. So the negative area means that the function itself is going down, 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 down. Okay? So starting from x equals from 0 to t is negative until t equals negative 2, when the f prime starts being positive. In fact, this is probably an easier way to explain this. Just say if f prime is negative until negative 2, then the function's going down. Okay, then f prime is only positive, so a graph never goes down again. Okay, so x equals negative 2 is the absolute minimum. Okay, then the graph has much more positive area from negative 2 to x equals negative 2 to x equals 4. So the graph must rise above its initial value at x equals negative 4. So what I'm trying to say is that because there's all this positive area under f prime of x, then the graph must go up much more than much higher than this initial value. So because this area is more than this negative area, the graph goes up more than it went down. So it went down until x equals negative 2, and then the graph went up, 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 up. So this must be the absolute maximum at x equals 4. So that's the point I'm trying to get at there. Okay, so that's 3 questions from both AP and BC Calculus. Now I get to go back to using my calculator. Let's have a look. The function f is defined by this utterly disgusting nightmare. That looks like something that deserves a calculator. And then the function g is defined by this rational function. Graphs of f and g are shown below. Okay. For x greater than 0, the equation y equals g of x can be rewritten as x equals h of y. So we're just taking an inverse, okay? The graph of h of y and the horizontal line y equals 3.5 are shown in figure 2. Okay, I'm like, why are you asking me to do that? Let R be the region bounded by the graph of g, the x-axis, the y-axis, and the vertical line y equals 1. The graph of g, just the graph of g. Yeah, okay, so just the graph of g, okay? Find the area. Okay, if you say so. Well, the area is going to be the integral from 0 to 1 of 14x plus 12 over x plus 12 dx. Okay, let's find out what the devil that is. Let me just load both these functions into here. I might need them again. 1.43 raised to the power x plus 0.57. Heaven only knows why. Okay, and then 14x plus 12 over x plus 12. Sure, whatever you say. Okay, no skin off my nose. Okay, let's do function numerical integration. I did not mean to do that. No, that's not what I meant. Go back to the main screen. Okay, main screen, turn on. All right, it's you. Okay, we're going to do it's stored in Y2 is where my G is. Let's see what it says, 1.51. Yeah, I believe that. That looks like 1, and that looks like a half. Okay, so 1.513. Awesome. Region R described in part A is the base of a solid. Of course it is. Why wouldn't it be? Each cross section is a rectangle whose height is 1/3 times the length of the base in region R, right? But do not evaluate an integral expression that gives the volume. Okay, so d volume is area dx. So volume is integral area dx, and the area, this is the area has, this is the base, and then it's coming out like that. So can you kind of see these rectangles coming out like that? These are the rectangles coming out like that. Okay. So area is going to be base times height. So it's going to be g of x, then that's the base, and then we're told that the height is 1/3 of g of x. Yeah, okay, g of x dx, and we're just going to integrate from 0 to 1. And that technically is correct, okay? You don't have to simplify it. You don't have to say 0 to 1 of 1/3 g of x squared dx, or heaven forbid, 1/3 integral from 0 to 1 of 14x plus 12 over x plus 12 all squared dx. It says don't evaluate it, so I'm not gonna. Okay, the shaded region in figure 1 is bounded by the graphs of f and g from 0 to a. Find the area of the shaded region. Okay, so the first thing I need to do is I need to find where the other crossover point is. Okay, so what I'm going to do is I'm going to zoom decimal. Okay, and I didn't really need to see the first quadrant, so screw you, screw you. Okay, so that is f. That is f. Here comes G, and of course it goes off. Why would it ever not go off? It goes off the screen. I didn't mean that. I meant times 2, which is 6.2. Can you tell it's a Freudian slip there? Okay, so it's going to painstakingly, obviously it's really tough to calculate exponents there. Okay, so let's calculate an intersection. Okay, we're going to intersect. Okay, so first curve, second curve, guess. Yay. 3.256. So I'm going to say this. I'm going to write this. So this is my part C response here. On part C, I'm going to say this. I'm going to say I use my TI 84 calculator to get the intersection and find that A equals, what did I say, 3.256. Okay, all good. Now to find the area. Okay, the area is going to be this. Now let's pay really close attention to what's going on. Let's find where the freaking front page of this. Oh, here it is. Okay, so f is on top and g is on the bottom from 0 to 1. So the area is going to be the integral from 0 to 1 of f of x minus g of x. Okay, dx, and then we're going to add to that the integral from 1 to 3.256 g of x minus f of x. Now, why am I doing that? Because now g is on top and f is on the bottom. Okay, do you see how that works? G is on the top and f is on the bottom. So if you did not do this, if you went from 0 all the way to 3.256, you counted one as negative and the other one's positive. That is not the actual area. Okay, so what I'm going to do now is I'm going to do integral from 0 to 1. F is going to be stored into y1 minus y2. Okay, so this is going to be 0.259, and then we're going to swap them. Oh, heck, I don't feel like swapping them. I'm just going to do 1, 2, 3.256. Okay, it'll come out negative, but then I'll just negate it. So I'll just do the negation of that. So 0.323. So if I take 0.323 and add to it this other fella, then I'm going to get 0.632. Okay, so that's the area. The area is that. Okay, let T be the region bounded by the graph of x equals h of y, the y-axis and the horizontal line. Let T be this region. Yes, okay, T. Right, but do not evaluate an integral expression that gives the volume of the solid generated when T is revolved around the y-axis. Okay, so what I got to do is I got to make disks. Okay, so the volume of a cylinder, R, H. The area of the base, pi r squared times the height. Okay, so the D volume is going to be pi r squared times dH. Here, dH is actually dy. Okay, and r is actually x. Okay, so this is a pi x squared dy dv. Okay, so v is going to be pi the integral, and what is x? H of y. So 12y minus 12 over 14 minus y. Okay, squared dy, and we're going to integrate from 0, 1 from 1. Okay, y equals 1 to y equals 3.5. All right, that's what I think it was. Okay, more AP Calculus AB. This is no calculators now. Okay, a remote-controlled toy car moves back and forth along a straight path, so its velocity is given by this piecewise function. Here's the graph. Find the acceleration of the car, that's the derivative velocity. This is absolutely my wheelhouse because this is physics. Okay, so I'm going to take the derivative. So dv dt evaluated at time equals 1 is equal to 4t cubed minus 24t squared plus 32t. Okay, we're going to evaluate this at t equals 1. So 4 minus 24 is negative 20, and plus 32 is 12. Does it say that I have to put it's going to be feet per second squared. It doesn't say I had to put units, but I'm a physicist. I have to put units. Okay. Can I just tell you something? My wife's a nurse, and she'll quote numbers to me that mean nothing. Like she'll be like, "Oh yeah, his blood oxygen was 88," and I was like, "What are the units of that?" She'll be like percent saturation of your blood, and I'm like, "Is that bad?" Yeah, it's really bad. It should be 99 to 100 most of the time. Oh, thank you so much. Yeah, his blood pressure was like 180 over 120. Okay, first of all, what are the units of that? Like millimeters of mercury? Okay, fine. She makes her crazy that I ask her for the units of things. Okay, is a car speeding up or slowing down at time equals 1 second? Now, understand something clearly, okay? Speeding up means that the absolute value of v is increasing, and slowing down means that the absolute value of v is decreasing. Okay, so at time equals 1, this is pathetic. It's speeding up because the absolute value of v is increasing. That seems like an insult to my intelligence and yours. Okay, find the distance in feet that the car traveled from 0 to 4 seconds. So delta distance is the integral. I'm going to use d. No, you don't want to use d because that's a differential operator. I'll just use capital D. Velocity d time. Why do I feel like I'm walking into a trap here? No, I'm not walking into a trap at all. What trap was I afraid I was walking into? Well, here's the deal. If you are given a v versus t graph and it does this, and they ask you for the distance, you have to take the integral here and the integral here as absolute values and add them so that they only count as positive. But thankfully, I can tell that I don't need to do that because this test is dumbed down. Okay, so we're going to take the integral from 0 to 4 of, what was that up here? T to the fourth minus 8t cubed plus 16t squared dt. So that's going to be 1/5 t to the fifth minus 2t to the fourth plus 16 over 3t cubed from 0 to 4. Well, plugging in 0 into a polynomial that just came off an integral always results in 0. Now we're going to do this. And let me tell you right now, I am not fucking simplifying this. Okay? I am not simplifying it. I'm not simplifying it. I'm not simplifying this. I'm not simplifying it. I'm not going to simplify it. That's good enough for me. Okay, that's the, okay, now I do get to use a calculator because I'm a grown-up, okay? So grown-ups get to do all kind of things that kids don't get to do, like drink alcohol and not have to do calculus. 4 raised to the fourth plus 16 over 3 times 4 to the third. Okay, it's going to be an ugly number, of course. If I turn it into a fraction, will I regret it? 512 over 15. Wow, that's such a dissatisfying answer. Okay, find the average velocity of the car over this interval. Show the work that leads your answer. Okay, so I'm going to talk physics first, and then I'm going to talk calculus. Okay, so physics first is going to be average velocity is your net displacement over the total time it took. And now I'm going to talk calculus. Net displacement is going to be the integral from 6 to 12 of v dt all over 12 minus 6. Now for this, it's going to be, oh gosh. Okay, integral from 6 to 12, 12, 10 cosine pi over 3t minus 10. This will just be a 1 over 6 out in front. Okay, all good. That's the answer to the previous question. So cosine integrates up into sine pi over 3t. The inside will flip out, and it's like the reciprocal of the chain rule. Okay, you can use any kind of U substitution if you want, but because I'm me, I don't need to. Okay, 1/6, and then I am going to plug in 6 and 12. When I plug in 12, I get 4 pi t, and that makes this 0. And then I'm going to get negative, so I'm going to get 1/6 of negative 120, okay, minus. Now, if I plug in 6, I also get nothing, okay, so this becomes minus negative 60. Okay, this is like a fucking joke. It's just negative 10 feet per second. I don't actually believe that. Okay. So, with your permission, I am going to play a game called What is 10 cosine pi over 3. This is the part where I tell you, if you're still paying any attention and watching this video, that I did not actually rehearse these before I got on the screen with you. Yeah, look, okay, 0, 5, negative 5, 15, 20, negative 15, negative 5, 0. That's got to average. That average to 10? That doesn't feel like it should average to 10. Okay, I'm going to do this. Okay, I'm going to go ahead and just let the calculator work its magic here. Okay, I know it's no calculator's part, but shut the hell up. Okay, that's my opinion. I'm sticking to it. Okay, so we're going to do 10. It's up here. Cosine pi over 3 times t minus 10 dt. Yeah, okay, when I divide that by 6, because that's the width of the interval, it's negative 10, whatever. Okay, it's not my fault. I didn't make up this stuff. Okay, last question. Finally, couldn't happen soon enough. Oh, wait, I still have BC questions to do. Oh, frick. Okay, so, and it's getting late. The function f is twice differentiable. Cool. The table gives values of f and its derivatives. Find, oh man, why do I don't want to do this. Find the limit as f of x over x, or state the limit does not exist. Is this just an invitation to L'Hopital's? So limit as x approaches to, well, first of all, f of x is 3 and x is 2. I don't have to do L'Hopital's at all. What a rook. Did you do L'Hopital's? You don't have to. It's not an indeterminate form. It's just 3 over 2. 3 over 2. 3 over 2. Why is it just 3 over 2? Since f is continuous, given it is twice differentiable. Okay, so because the function is any differentiable, okay, any differentiable in any way, it must be continuous. And if the function's continuous, then the limit, if it is not an indeterminate form, if it just comes out to this, 3 over 2. I wonder how many people got rooked on that. Do you see how close I was to being like, ooh, it's time for the L'Hopital's rule. Better not check if it's an indeterminate fucking form. Okay, let G be the f of x. God. Find G prime of 2. Wow. Okay. What would G prime be? G prime would be f prime of f of x times f prime of x. That is the chain rule. You take the derivative of the outside, keep the inside, then multiply by the derivative of the inside. So G prime at 2 would be f prime of f at 2 times f prime at 2. F prime at 2 is 4. F at 2 is 3. So this would be f prime at 3 times 4. F prime at 3 is 9. 9 times 4 is 36. Let h be a differentiable function so that h at 0 is 10 and h prime of x, why me, equals f prime of 3x. Find h at 2. Show the work that leads to your answer. Find h at 2. Oh, they may have me at this one. Okay, so I'm going to say this. I'm going to say if h prime is equal to f prime of 3x, then h I'm going to say this, h at x minus h at 0 is going to be the integral from 0 to x, h prime of t dt, integral from 0 to x of f prime of 3t dt, and if u equals 3t, then du equals 3 dt. So I have to put a 3 dt here, so that's a 1/3 there. So h at x minus h at 0 will be 1/3 integral from 0 to x of f prime of u du. And so that's just f prime f at u, 1/3. Do I want to change these bounds? This is t equals 0, t equals x. So if t equals 0, u equals 0, and if t equals x, then u is 3x. So I'm going to say f at 3x, this is h of x minus h of 0 is equal to this. So h at 2 minus h at 0 would be 1/3 f at 3 times 2. F at 6 is 5 times 1/3. And then this is h at 2, and then h at 0 is 10. So I'm going to say that this is h at 2 is 10 minus 5/3. Okay, I must have made a mistake in there somewhere. I don't feel like that's the right answer, but whatever. Okay, let k be the function defined by this. Find k prime of x. Okay, so I'm going to call this function, I'm going to make it up, I'm going to say g of t is t squared f at t, and here's why, because I can never remember the fundamental theorem of calculus. I just can't remember it, so I have to redo it like every time. So this is the integral from 0 to x of g of t dt, which I'm going to say is g at x minus g at 0. Okay, that is k, a function of x. Then k prime of x must be g prime of x, and then this is a constant, so it goes away. Okay, so what is g prime? Is just the original g. So k prime, it can't just be that easy, is it? I think it is. I think k prime of x is just x squared f of x. Okay, and then the second derivative, k second derivative, is going to be this product rule: 2x f of x plus x squared f prime of x. Okay, so k double prime at 3 will be 2 times 3 times f at 3, 8, plus 3 squared times f prime at 3. F prime at 3 is -2. So it's 48 minus 18, so 30. I have no idea. That's my best guess. Okay, so time for the BC calculus stuff. Okay, so this is the yes calculator on BC calculus. Let S be the shaded region bounded by this graph of polar figure. Okay, it can be shown that did you seriously just take the derivative for me of this? Oh yeah, your calculator should be in radio mode, a-hole. You seriously just took the derivative of this. Like, this is BC calculus. How stupid do you think I am? I can't take the... Okay, find the area of the region S. Show the setup for your calculator. Okay, well, how the fuck do I do this again? So the idea is it's like a little tiny triangle. And that side is R, and this side is a little tiny theta. And so this is a little tiny r d theta. So the area of this little triangle is 1/2 r times r d theta. So the tiny area is one. Can you tell I don't have it memorized? I don't have any of this shit memorized. Okay, I have to redo it every mfing time. I have to redo it every time. Okay, so I'm going to say the area is going to be the integral from 0 to pi. Okay, and this is yes calculator, so I'm actually going to do this. 1/2 times 3 plus 2 sine 2 theta plus cosine 2 theta, all that bullshit squared. I'm telling you, when I start getting tired of math, I start using the naughty language. Okay, let's set my calculator on the polar mode because I may want to do that. And we'll do 3 plus 2 sine 2 theta. That was it, wasn't it? Plus cosine 2 theta. Okay, I think I did that crap correctly. Did I put the 2 in front of the sign? Yes, I did. So then I'm going to functionally numerically integrate, even though I could actually, no, I don't think I could actually do this. Maybe you could do this integral, but it'd be super sucks to do. Polar R1 squared d theta, and it sucks. So the area is 36.128. Do I actually believe that? What is this number? Go back. Okay, so this is 4. Okay, let's do R1 of pi over 2. Okay, so this is 2. And then R1 of just pi is 4 again. So a base of 8. Maybe I believe that this could be an area of 36. Did I put the 1/2 in front of it? I bet you I forgot to. Yeah, I think I forgot to. So it's actually this divided by 2. This is much more plausible. 18.064. Okay, that's more plausible. Okay, there is a point on the curve. Yes, there are many points on the curve at which the slope of the line tangent to the curve is -3/7. At this point, dy d theta equals that. Find dx d theta at this point. Are you serious? Like, is this a joke? Like, okay. The slope of the line tangent is dy dx, which is -3/7. Okay, I feel like I'm being pandered to. Dy d theta over dx d theta is the same as dy dx. So if I cross multiply, then what I will get is I'll get this. Dx d theta cross multiplies up, and then the -3/7 cross multiplies down. The dy d theta stood there, and it was 3 radical 2 over 2. So then this 3 and this cancel out, and you get -7 radical 2 over 2. Okay, that's it. Okay. Like that's demoralizing. That felt too easy. Okay, find the value of theta in this interval at which r has a critical point. Okay, so you mean like where the value of r is the derivative. Oh, well, let me just do this. Okay, so this is a critical point is where put f prime r prime equals 0. So when's that going to be? Let me just show that to you up here. Okay, so I don't really need a calculator. 4 cosine 2 theta minus 2 sine 2 theta equals 0. So 4 cosine 2 theta equals 2 sine 2 theta, which means that, 4 over 2 equals sine 2 theta over cosine 2 theta. So we have tangent 2 theta is equal to 2. So then that means that 2 theta is the inverse tangent of 2. So theta is going to be 1/2 the inverse tangent of 2. Okay, here we go. It's going to be the inverse tangent of 2 over 2, and that gets me 0.554. Use a derivative test to determine whether the critical point is a relative max or you can see it from the graph. It's a relative maximum. Okay, so now I'm going to take the second derivative. Okay, so the second derivative, this should be pretty easy. R double prime of theta should be cosine switches to negative sine. We're going to jump out from the chain rule, make 8. Sine 2 theta minus sine is now still cosine with the same sign. Okay, so the sign of sine is the same when it becomes co-sine, and then we jump out that. Yeah, it's sine and sine, like sine, the function, and sine positive or negative. I have to start spelling them out. This is negative. This has to be negative, okay? So I'm going to say this. I'm going to say r double prime of theta must be negative at, theta equals 0.554, which is, between theta and pi over 2, right? Why? Because both cosine and sine are positive, and r double prime has two minus sign terms, okay? So because this is r double prime is negative, it's concave down if you just graph r versus theta like a normal human being. So this is a local max. All right. Find the average distance from the origin to, this isn't even about polar curves at all. This isn't even about polar curves. Find the average distance for this. Show the setup for your calculations. So average anything is the integral of the function divided by the interval. So it's going to be pi minus pi over 2, and this is going to be pi over 2 to pi. Okay, so then integral pi over 2 to pi of 3 plus 2 sine 2 theta. So this isn't even about polar curves, really. Like, where did I do? I did polar here, and I kind of did polar here. But the rest, part C and D, really could have been about any normal Cartesian function. Okay, pi minus pi over 2, which is just pi over 2 itself. Okay, so let's just go ahead and get the calculator to do it, get it over with. Function numerical integration from pi over 2 to pi. Okay, and then the y vars is going to be the r1 d theta. Then we're going to divide that by pi over 2, and I get 1.727 for the average distance. All right, that's my story, and I'm sticking to it. Okay, screw you, Slopefield. Okay, what's this? Let f be a function defined by this bullcrap, and then let g be a function defined by that hogwash. The graphs of f and g intersect at that point, like I care. Okay, how does this affect my life? Let R be the region bounded by all this stuff. Evaluate this. Are you for real? You're just, okay. Integral from 1 to 2 of x minus 1 to the 1/3 power dx. Okay, well, I'm not going to do u equals x minus 1 because then dx is just du, and that's a waste of my freaking time. So that's going to become x minus 1 to the 4/3, add 1 to the power, divide by the new power. Okay, sorry. And then we're going to plug in 1 and 2. When you plug in 1, you get nothing. When you plug in 2, you get 1 to the 4/3, so that's 3/4. Whoopty shit. I'm actually going to just test myself. Like, is it just this easy, and I'm like pissy about it, or am I just screwing up America here? Okay, so just x minus 1. Oh, shove it, stupid radical notation. E to the negative 2x plus 4. Okay, so let us ask the function numerical integration tool to go from 1 to 2 of y1 dx, and I get, wait for it. Okay, yeah, basically 3/4. That's some error, and it's a little picket fencing. Okay, right, but do not evaluate. Why would I ever evaluate anything? An expression involving one or more integrals that gives the glorious, the volume of a solid generated when region R is rotated around the x-axis. Okay, so what I'm going to do is I'm going to do this. Now, if you saw earlier in the video, I remembered that if this is dx and this is y, then the d volume is the area of the base, pi y squared, like pi r squared, and then times the tiny height. So the volume is going to be pi integral f squared dx, and that's going to be from 1 to 2. And so it's going to be integral from 1 to 2 f, which is going to be x minus 1 to the 1/3 times 2 is 2/3 power dx, and then that's it. Okay, I'm done with that. Okay, right, but do not evaluate. Yeah, okay, that's it. An expression following one word that gives the perimeter. Oh wow. Okay. If you say so. So here we go. The perimeter is going to be 1 for the base, 1 to 2. That's this piece right here. Plus 1 for the height on the right. And then, oh my gosh, I got to remind myself, how do you actually take the what is the arc length? I don't actually remember it. I believe I have to integrate from 1 to 2. And then it goes something like this: tiny length squared. That's a little tiny s squared there. Tiny x squared, tiny y squared. Okay, so ds squared is dx squared plus dy squared. There's a little tiny dx, a little tiny dy, and this little tiny length. Then what I'm going to do is I'm going to divide everybody by dx squared, divide everybody by dx squared, divide everybody by dx squared. This becomes ds dx all squared equals 1 plus dy dx all squared, which is ds dx all squared is 1 plus f prime squared. So then I take the square root of 1 plus f prime squared. That's ds dx. So then I dx. Okay, so good. All right, so from 1 to 2, 1 plus, okay, f prime. So now I have to do f prime. So if f is x minus 1 to the 1/3 power, f prime is going to be 1/3, multiply the power, x minus 1, and then negative 2/3. So f prime squared will be 1/9 square u. And then when we square u, we actually double the exponent. So then that'll be 1/9 x minus 1 to the negative 4/3 dx outside the radical. Okay. Evaluate integral from 2 to infinity. Seriously, this just doesn't even, okay, now I have to do this officially, by the way. I can't just leave infinity as a bound like we do in AP Physics, because physicists don't give a damn, okay? But I have to actually like make this official. I believe I have to do something like limit as b goes to infinity of 2 to the b e to the minus 2x plus 4 dx. Okay, now I can't do this. So du, u equals negative 2x plus 4. Du equals negative 2 dx. And so that means that dx will be negative 1/2. I'm channeling my inner Truman Capote here. Okay, I know you think I sound like a character from South Park, but I'm actually trying to sound like Truman Capote. If you don't know who that is, then you're an asshole. Okay, so I've got either u. Oh shit, I need the one. Oh yeah, there's a negative 1/2 here. There's a du, so he's just his own integral. So e to the negative 2x minus 4. This, I don't know. This doesn't feel like AP calculus. Can I just tell you? I have to fucking. Okay. Now. Okay, I have to really do this. Limit b goes to infinity of negative 1/2 of e to the negative 2b plus 4, and this, well, the limit is going to make it go to 0, minus e to the minus 2 times 2 plus 4, which is e to the negative 8. So the answer is just positive e to the negative 8, because 1/2 out in front. Yeah, whatever. I don't know. I mean, hey, well, let's just ask the fucking calculator. Okay, so what am I integrating from and to? I'm integrating from 2. Let's say integrate from 2 to like 10,000 or something like that. And then this will just be y2. Okay. What the fuck? Why is that so small? That was not okay. Something bad happened there. Let's just do this. Okay, are you going to be less offensive than that? 0.5? Seriously? Is it because 0.5 e to the negative 8 is like super small? No, that's not a good reason. I don't know why. Okay. I don't think the calculator can do limits to infinity, and I'm just not going to ask it to. Series. Why so series? Oh my gosh, I've been at this for more than an hour. The Maclaurin series is given by that crap. And it converges to this function g, as long as you stay less than 5. For x greater than 0, the Maclaurin series for z is an alternating geometric series. Sure is, fella. Find g at 3. Oh, man. Okay, so how do you do this? The sum. Okay, so if it's the sum of ar to the n, starting from n equals 0, then that sum is a over 1 minus r. Okay, so then g at 3 would be a, which is 2, over 1 minus negative 3 over 5, which is 2 over 2 over 5, which is 5. Okay, the function f is defined by this hogwash. Write the first 4 non-zero terms of the Maclaurin series. Okay, so just take the derivative. Okay, no. Negative 2/5 plus 4 over 25x minus 6 over 125x squared plus 8 over 625x cubed. Okay, it seems too easy. The second degree Taylor polynomial for f about x equals 0 is used to approximate f, which is the derivative of g. F is the derivative of g, where f is the function defined in part b. Justify that this is not that much. Okay, so the second degree is this. That's the second degree Taylor polynomial for f. So what I'm going to do is I'm going to evaluate the third, the next term up. So the next term up, I'm going to plug in 5 over 2. So the next term is 8 over 625 x cubed. So the error is 8 over 625 times x cubed. And x is 5 over 2 all cubed. So that's going to become 8 times 5 cubed over, this happens to be 5 to the 4th power, and then times 2 cubed, which is what 8 is. So then this goes all the way down to 5. So yes, so the next term at x equals 5 over 2 is 1/5. So the error must be less than 1/5 since this series alternates. Yeah, so the error in the approximation is less than the next term if the series alternates. The function h is defined by this stuff. Write the first 3 non-zero terms of the Maclaurin series for e. Cool. Here we go. 1. That's first 3 non-zero. That's non-zero term plus x plus 1/2 x squared. Okay. Write the first 3 non-zero terms of the Maclaurin series for h. Cool. Okay, so it's going to be 25 times. This is g, isn't it? Yeah. 2 minus 2/5 x plus 2 over 25 x squared. Okay, that's 25g minus 2, 1 plus x plus 1/2 x squared. Okay, so this is going to be 50 minus, oh my gosh, 10x, and then plus 2x squared minus 2 minus 2x minus x squared. So we're going to get 48 minus 12x plus x squared. That is the first 3 non-zero terms for h. Okay, this took more than an hour. It takes me more than an hour every year, and it sucks out my soul. Goodbye.